Hello everyone, my name is Anfal and I am going to talk about AI augmented engineering. And I apologize I baited you all with the title. It is vibe coding, but it's more like augmenting yourself with AI instead of just blindly trusting the AI. So let's move on. People vibe code with AI, and AI is unpredictable. At scale, when we're working in bigger organizations, we've got hundreds of engineers, 10 plus engineers per team, so we can't really deal with unpredictability. If something happens with millions of users, we'll be responsible, we'll be waking in the night, so yeah, that's not something we want, so we have to make the AI work for us instead of just using the proverb, Jesus take the wheel. But yeah, that's all good. But the question is, why should you listen to me? Like, why am I an expert in this? I've been tinkering with AI, especially Gen AI, for the past 4 years, and I've created an AI debugging tool for vibe coders as well. So I deeply and intimately understand the vibe coding community. And I have been exploring this AI augmented engineering space for the past 2 years. And I am trying to implement it in the brownfield projects in our current company. So yeah, it's the demo time. And I do apologize, I have to go through quite a lot of stuff, so I'll take Q&A after everything is done. So for the sake of the demo, I am not going to show you a simple CRUD application. I want to show you something that's fairly quite complicated and tell you about like how you can use AI in it. So as an example, this system is basically a DSL that I wrote on top of React, and it allows you to generate UIs using JSON-based DSL. Now, if you look here, let me...
Command plus a couple times?
Yeah, sure. Let me see. No, I don't think it's gonna do anything.
Oh, yeah.
I'm gonna see if I can raise the resolution. Oh yeah. How about now? Looks like, yeah, you should be able to see it now, right? Yeah. Okay, yeah, so let's look at this DSL, and it's completely contract bound. It inherits the concepts of atoms, molecules, and organisms. So contract gets created on the atomic level. So as an example, this is a div atom. And every atom is exposing a contract. So we've got a prop schema, and this is what it looks like. So if it says something needs to be present, like this is not an optional property, the organism that gets built has to have it. Otherwise, it's going to show you an error. But it just doesn't stay here because we're talking about AI and not the developers. So we need real live feedback, and that's where the application comes in. So you see that the error is immediately displayed, and if we go down here, we can see a very clear error that class name is missing. So it's just to show you that the system is showing both the developer the errors, and at the same time, it's giving very verbose feedback to the AI. So now let me show you the system. So this is a meta framework that I've written on top of Cloud Code. And let me open it here. And we've got some commands, very generic stuff. But if we go inside the framework itself, you're going to notice that we've got the existing architecture, project mission, whatever you're working on, methodologies, which are like atomic commit guidelines, different software engineering best practices, basically. And then we've got the playbook. This playbook is basically circling around things. For example, how do you build an organism in this system? So it's more like an engineer is going in and they're creating these playbooks for the AI to follow. And similarly, we've got templates. So as an example, you can see that an atom agent template, meaning it just gives the full picture to the AI on how to create something in the system. Now, I'm gonna run it. So we've got a very nice, neat little command called initkai, and once we run it, it's gonna read all the files, and it's gonna basically put everything in its effective context memory. So we're just gonna wait for it. And one thing that I want to mention is I don't really care if AI is going to do a good job on building this, in one shot, because I want it to fail, because I want to show you the other side as well. Like, I just don't want to show you the AI doing everything fine, because that's not, our daily life. So let me grab a prompt. And as you can see, there's nothing special in here. It's just like, I'm just asking it like, hey, I want to build this feature. So I'm just gonna paste it here, let the AI do its work. So what this system does, like while it's working, I wanna explain what it's doing. So it has all the context, like best practices, information about the system, whatever I have in its context memory. Now I have given it a command that, hey, I want to build this feature. And now it's just coming up with a prompt for a secondary agent, because it's not like everything is going to be done by this agent. It's going to be done by a sub agent that you can just have it do the work and then discard it completely. So, and the reason for that is basically separation of concerns. This is the orchestrator. This deals with all the knowledge, orchestration, brainstorming related work. And then we've got the actual agent that does the implementation. So we've got, let's see, workspace structure, execution plan and coordination. Just give me, I'm just gonna put it down. I'll just put it here.
In the end.
Yeah, I mean, it's just going into that Q&A mode, and I just want a command for him, like prompt from it. So yeah. Okay, now you can see it's creating a workspace and it's creating a product comparison prompt for it. So let's just let it have a go at it. So yeah, if I close Kai, I can show you what the workspace looks like. This is where all of your work's gonna be. So every feature that you develop is going to have prompts. It's going to have an agent log, because you just don't want to blindly trust the AI. You want to analyze its output as well after it's done doing its job. So let's let it have it, like create its prompt, and then we'll go for the next phase. I just need to wait because AI is slow.
So are you prompting to get a prompt?
Basically,
Okay.
yeah. But this prompt is very focused because you've got all the context of the project, best practices, as I was showing you, Git commit, like what to do in that case and all that. So this one is basically an orchestrator, and it's creating a prompt for a sub-agent to do the actual work. But it has to, like the prompt itself is going to be really descriptive. It's going to tell it where the directory is, where are the contracts, where everything is lying, how to build it. So it's going to give it a full-on picture of the entire system. Yeah, I just fixed that issue as well, so that should be gone as well. Yeah, you can see now that issue is gone. Yeah, I mean AI is slow. Meanwhile, while it's happening, like if you have any questions, I'm able to answer that. Yeah, please.
I was wondering, like, when you said about like having this agent triggering another agent, is it a case of like you could use Sonnet, for example, to get a clear plan, and then once the plan is really clear, you end up like delegating this to Haiku for price consciousness?
Yeah, technically you are able to delegate that task to any AI, like it's not related to Sonnet. I have personally experimented with a system where I was delegating the calls from Cloud Code to Gemini. So you're able to do that. You're not basically restricted with anything. Yeah, I saw a hand over there as well.
Yeah, I just want to ask about the context size. So do they try with slash context just to see like how much context you have versus the communication?
Yeah, of course, we can definitely do that. I don't want to disturb the other parts. I'm just going to do it here. So once it's done, I'll show it the context. Okay, so we are done. I think so. Let me just go and see. Yeah, right here. So, and why is the shell so big? Okay, so yeah, you can see right here. It's giving it very laser focused information, like the front end information, the version that we are using, states, styles, user flow, and it's a very big prompt. Like it's giving it literal code on how to do things. For example, there is a restriction that you need to have type box based contracts built before you can build the organism. So it's very descriptive. Okay, so it's done. So what I'm gonna do is just copy this and paste it in my next agent and have it do it. So while that's happening, I'm gonna show you the context. Yeah, by the way, please keep one thing in mind. This is my personal account, which is sort of like, I'm using a smaller model. I think it's like 120K tokens or something. But usually at my day job, I'm using Sonnet 4, which is like a 1 million token language model. And it has plenty of room where I can do the entire days of work and I never run out of space. Oh yeah. It's a very descriptive project. Like you are putting it all of your tribal knowledge of your project inside this folder. So it's gonna have a lot of description in there. So this is one of the cons with the system, that you cannot really work with like a 200K tokens or 120K tokens model. You need like a million token model. And Cloud for Sonnet is really good for that, the 1 million token version. Of course, yeah. And if your project is small, you're not going to have all this. And one more thing, I also have like a lot of MCPs installed. Okay, so let's see what it's doing. Okay, I think it's working. Let me just expand it a little bit more. Yep, it's doing the job. So you can see it's doing the default style contracts. Everything is happening. So I'm just gonna let it do its job. And while it's happening, are there any other questions? Okay, good. So while it's happening, I wanna continue with my slides because I don't wanna delay. Let me go down here. Okay, so what I am showing you right now is sort of like one single agent doing one job, and it's very sequential. So if you were to do it in your production environment, like in your office, that's not gonna work. So that's where the concept of parallelization comes in. I am not going to go into it, but this diagram explains it. So there's a feature in Git called Git work tree, which we basically use to create a parallel work tree environment, which has everything in the main repo, including all the history, Git tree related histories and everything. So it's kind of like the same repo, but in a different folder. And once you've got that, the main question people usually ask is, AI is going to generate thousands of lines of code. So like, how do you effectively, code review that? And the answer is, number one, you use another AI like CodeRabbit. And the second question is, second answer is, you basically do stacked pull requests. GitTown is a good tool for it. It's basically, it allows you to stack one pull request on the other. So you can create a pull request for the previous. So it's like, I can install the dependencies, build, submit a pull request, then write the boilerplate, submit another pull request. So you can basically stack these pull requests and get them code reviewed individually. So the overall load on the engineers is not that high. But once you start parallelizing your work, of course, you're going to be creating a lot of code. So you need AI in the CI/CD pipeline as well. Okay, so a few questions that I personally had with AI, and also a few people have raised them as well, is AI promotes brain rot, which is effectively called decay theory. And I would personally agree, but the question is, what are you trying to protect? Right now, our job was we would write the code ourselves. But when we talk about AI writing it for us, it's basically transforming our job. Our job is like, we used to be developers before, and now we are acting more like engineers, and engineers architect things. They decide on how the things are going to work, what kind of system design you're going to use, the low-level system design, high-level system design, and then you delegate the job of writing the code to the AI. Another concern is AI makes me a bad software engineer, and my personal opinion is the quite opposite. As an example, when I was showing you the cloud folder here, yeah, methodology right here. So all of these things, it's not limited to just these atomic commits and all that. You can have system design practices and all those things as well. And before AI, if you weren't really a principal or staff level engineer, you wouldn't worry about these things. So AI is basically freeing up your time to go more into the architectures of things and the actual software engineering as compared to just the development of things. So it's a good thing that you should delegate the development work to AI. Before I go, okay, so it's still doing the type validation. This is one of the things that the contract bound things that this system does. It actually runs the type validations based on TypeScript as well. So the other thing is I can move faster than AI. It slows me down, which is absolutely true. You can probably write, you're a star engineer, you can write whatever you want. But the thing is, think about yourself as being part of a bigger team. Maybe your team has 10 engineers, your company has 70 engineers, or whatever that is. Now, if you were just doing everything by yourself or your team was just moving fast, then everything lives in your brain. And it's a tribal knowledge sort of situation. But if you try to have everything highly documented and in this meta framework, then the chances are you are going, and the next engineer that joins your company or the next engineers that's working on your project is going to have enough information or can work with AI directly. And this thing is reflected with this framework in my company as well, in my day job. I created this, and I can confidently say that my system can be worked on by any engineer who joins my team, and I don't have to spend any time onboarding or training them. And the fourth one is, if I'm effectively involved in the loop, how is AI increasing my productivity? And this one actually ties to this mindset thing that I have on the next slide. So when you think about AI, it's not a binary decision. You're not here to say, either I'm going to use AI or I'm not going to use AI. Think about it as a slider with that goes from 0 to 100. So if you're planning, brainstorming, you can go 50-50. You can just allow AI to just wipe code the entire thing, which is what I am doing. Like while I'm talking to you, the AI is building the feature. And this is really great because you can go through 6-7 different iterations within a week for whatever you're trying to build. And if you are working on something that is really complicated and requires your hyper attention, in that case, you can go 20-80 or 90-10, whatever you prefer. You can have AI write the code, but you manually approve every change that it's doing. And I have done that personally as well. So yes, I do agree that it does decrease the productivity if you are involved, like 90% of involvement is on your end. But think about it this way. If you were using Context 7 MCP or any other MCP that distills the knowledge that you're getting, it's going to effectively cut down your time on some scale. Like it could be minor. If you're moving on a slider, you could save like 10-20%. If you were just letting the AI do everything, it could be like a 90% time save. But you will save time as compared to just doing everything on your own. So yeah, and I have a blog post for this where I am posting all the URLs, and I intend to open source this meta framework as well. So you guys can use it in your greenfield and brownfield projects. It's completely modifiable. It's totally based off of prompts, so you can modify it however you want. This system is not open source yet because I am passing it through a few testing phases, but I will do it very soon. So if you start it, you will get a notification for it. And we are going through TypeScript errors in organization. So yeah, you can see right here that it made a mistake and now it's fixing it on its own. So this is the contract-driven development that I was talking about. Everything that you do is going to be contract-driven, and AI will get an instant feedback about it. It is taking a bit of a time, so I'm just gonna manually show you the rest of the few things. So once the agent is done its work, it's going to write a log, which is going to tell us what it did, why it made a decision, and what was the end result. And then the orchestrator agent is going to use another command, which is going to be validate agents, which is basically going to pick up that log I'll show you the command for that. Yeah, so you can see validate agent, then the feature ID. Feature ID is basically the workspace folder name where you were doing your project, and it's going to evaluate how good of a job AI did in writing the code. And once it does that, it's going to either say it did a good job, we can move on, or it's going to create a bug fix prompt. So whatever got broken, it's going to create a prompt for you to fix it. And again, prompt, copy it, paste it in another agent, and have it run that prompt. And yeah, you have to copy and paste it in a brand new agent, and that's kind of like a best practice because the effective working memory can get polluted if it has like multiple contexts in there. But that's not a problem with this meta framework. It's kind of like a problem with AI in general. And the other thing is, if there is a concept of context decay in terms of language models as well. So even if someone says like I'm using a 1 million token model, the effective window is roughly somewhere around like 200,000 tokens or maybe less. So if you end up in a situation where you're looking at the context like we did here, and you're like, oh, I have consumed 500,000 tokens, and now you can see it's like doing the playwright thing as well, and basically checking whether it's doing a good job or not. But like I'm gonna let it do it, but I'm just gonna complete my talk. So it's gonna you can basically use this command like create session handoff, and what it's gonna do is it's gonna take all the context that the orchestrator has, and it's going to dump it in a file that you can share with the next agent, and it's gonna continue from that point onwards instead of just starting from scratch. And someone could say we can use a /compact command for it as well, which is true, but the thing is you cannot control compact, or like you cannot control how it's implemented. But in this case you can, because this is just a prompt, and you can modify it according to however you want to compact your session and hand it over to the next agent. So yeah, it's this is in a nutshell this meta framework that I'm working with, and yeah, we'll just wait for it to complete its job as well. And meanwhile that's happening, if any of you have any questions, I'm more than happy to answer them. Cool, looks like we don't have any questions, and the AI is still working. So I'm just gonna leave it here, and yep, that's it. Oh, I can't see you. There's a light over there. So
Oh, yeah.
Literally. Yeah, sorry. Please go ahead.
Yeah, let's say a junior developer joins your team.
Yeah.
What would you recommend them? How much AI they should use?
I believe that they should be able to use AI as much as possible, because if a junior developer joins your team, there will be two things. Number one, they don't have a context of your project. And second, they are not going to follow the best practices. Like there are some high-level best practices for software engineering, and then there are best practices in your company, right? So if you are able to bake them all in this playbook that I was showing you, you can effectively hand it over to that junior developer and just ask them to keep an eye on the code, make sure everything is fine, and we're going to go through the code review anyways. CodeRabbit is a really good code review agent on GitHub. Like it shows you sequence diagrams and all those things as well, like how the code is written. So, and then there is the other gate where the stack PR thing that I was talking about, where you are going to review the code as well, right? So there are a lot of gates. So it's absolutely fine if they start using AI, but they shouldn't wipe code. Like they should be doing it through a proper channel.
Yeah, the reason why I asked this question is because the major issue with the junior developer using vibe coding and just relying on AI is that the slide you shared with mine about the mindset on a slider, how would they know what percentage of AI they should use? Like a senior software engineer does know when to slide down and start, jumping in and manual coding versus just vibe coding, when to whiteboard versus when to not whiteboard. But a junior developer, how would you make them understand this? Like if you have this agent that reviews all the code and let's say a bug comes in, how would they fix that if they haven't written the code?
That is a very good question. First of all, that is a problem with conventional coding as well. If a junior developer comes in, and they were writing the code by themselves, they can very well make a mistake without AI as well, right? So they have to learn how much of an effort to put and how to write simplified solutions. Like I have led junior engineers before, and they were writing really complicated solutions where all of the thing was doable by just a dictionary, right? So it's more like an experience-driven thing, and they can learn it over time while going through this process. The mindset is not exactly around whether to use AI versus doing conventional software engineering. It's more like our main jobs are changing. We are mostly acting like orchestrators, managers, and basically the architects of the system instead of doing the labor work of development, right? So and that's where the difference is. Like junior engineers, they can work with AI, but the senior that they become, they're gonna have this distinction that you were talking about, like when should I be involved versus where should I. And again, I have done this personally as well, and when I was involved in the complicated part, I was creating the foundation of the system, which a junior engineer is never going to do. They're only going to work on features in an existing system. So their job or building a new feature is very simple. Like as an example, in this demo, a junior, I'm just having the AI build this thing, right? So the system's there, the renderer is there, the only job the AI has to do is just build on top of it, using the contracts and everything that's in place, right? So like that's how you mitigate that. And yeah, looks like it's done. I won't have enough time for the validation, like to show you how it's validating, but I'm just gonna show you quickly the agent log. So that's where you can see like it's created organism contract, organism definition, default styles, everything. And very quickly, I just wanna show you that it's not breaking the overall system boundary. So it knew that within the organism folder, it needs to create a product organism. And if I compare it with an existing organism, you can see it has a default style in there. We've got a default style. And that default style is following the same practice that the other one that we didn't wipe code right now is following as well. And as far as the product comparison is concerned, let's quickly take a look at an existing organism. And then let's look at the product comparison that the AI created. So you can see that overall AI may hallucinate, but if you give it a contract-driven system with a meta system that contains the knowledge of the system, it's going to do a very good job, and it's going to take you a lot farther as compared to you just doing the job yourself. So yeah, that's yeah.
I'm just curious, where do you find that like this approach or methodology of prompting works better than just using the cursor?
Basically, as I said in the beginning, like I've been exploring this for like the past like 1 to 2 years, and I started from the same. And by the way, these questions that I was showing you, these are the questions that I was asking, by the way. So I wrote a blog about it as well, that I stopped. And if you go to my website, you're gonna see like why I stopped using GitHub Copilot, right? And it listed all the things like I wanted to write the code myself, and I wasn't able to do it. So that's where I just started the journey, slowly built on top of it. Then I built that debugging tool for the white codes that I was talking about. So all of that just gave me enough information like what needs to be there and crystallized for us to build a system that engineers can use and not just the white coders. So it's been a journey basically.
Oh, just for time, you're going to be around, Anfal.
Yeah, I am.
Okay.
So if you have any questions, just reach out to me, please. Thank you so much.
All right. Thank you, Anfal. That was great. It shows you that you can build things, but you can also build things that build things.